In this Integrity 9.3 internal training session, we are going to be looking at the new DNS activity feature. How this DNS activity feature helps organization to leverage DNS data to reduce risk. This feature builds on an approach to understand DNS behavior and configurations, and it simplifies the effort of architecting and deploying a suitable query logging infrastructure and can be implemented within minutes. Also, it ensures customers' DNS log data is efficiently and thoroughly captured and it's always accessible, which is critical for security and forensic analysis. DNS data analysis is becoming increasingly important as more and more applications rely on DNS as a trusted function. Okay, let's take a quick look on architecture. Our engineering team created an architecture that supports all functional requirements, and it has three main components. The first component is the configuration component, where the end user can configure the DNS activity service on BDDS through BAM UI or API, which is very similar to other available services today. Also, it involves two main modules on the back end. First is the DNS tap or bind module, and the other one is the vector log service. So when the user enables DNS activity, the front end, bind will enable and configure DNS tap in the back end, and it starts capturing DNS traffic and write this log in a DNS tap payload in protobuf binary format to a Unix socket in BDDS. And the vector log service read and ship this data in BlueCat JSON format, which is a common DNS schema for edge and integrity. Let's take a look on DNS activity feature in actions. And for this demonstration purpose, we are using BAM and BDDS VMs, Postman client, and a Splunk server. In this first demo, we'll see how to enable and disable DNS activity using BAM UI and how to configure the endpoints, how to filter, and how to configure the buffer size. Okay, first we'll make sure we have admin access, and as I mentioned in my previous slides, we have two BDDS server configured and deployed with DNS roles for this demo so that I can configure one with Splunk and the other one with HTTP output. Now let's see how to enable DNS activity on this BDDS1 under service configuration. I'll click the drop down to select DNS activity, and I'll click enable DNS activity logging, and here I'm selecting Splunk as an output, and I've already configured Splunk server with new HTTP event collector token. Copying the token value, and under global settings verify the SSL option and port number. Now we enter the Splunk host information here with the port number and enter the token value copied from Splunk. We can select health check if it is supported by the endpoint, and I'm going to select here the TLS option to enable SSL. And I've already downloaded the SSL certificate from Splunk server, and I'm going to select it here. Okay, upload. And just to make sure the certificate is valid. Next, you can select the buffer size and the type, whether you want to select it as a disk or memory, and you can configure the max events and max size. Filters are completely optional, and either you can select queries or responses or source address if you want to exclude those. And here you can see the values are pre-populated because I use this environment for API demo. I'm going to remove all this so that we can capture all the data. Now let's go ahead and update and wait for the confirmation that activity is running. And now here you can select DNS activity. And if you go to the bottom of the page, you will see the status there. Yes. So activity is running now, and we'll do the same thing on BDDS2 with HTTP as an output now. And we have already pre-configured the HTTPS endpoint with the vector service running as a listening port 9000. And as you can see, it's configured, and I'm not selecting the TLS option here, it's just HTTP. And I'm going to leave this exclude categories. and update. Now let's take a look at the Splunk output, and I'm going to generate some queries here for the BDDS 1 and BDDS 2. Now it's BDDS 2, and let's see whether the data is captured here or not. I'm going to refresh. Yes, I got the data here. The first one is the query. Here you can see the domain name and the response address and the source address as well, which is my mission. Let's take the second one, which is the response, and again it shows the domain name and the record type, the answers we received. Now let's take a look how to configure DNS activity service using API, and we'll configure buffer and the endpoint, and we'll change the output as well to HTTP. Here you can see two windows open. One is BAM, which shows two BDDS server. The other one is Postman with pre-configured API calls. And I'm going to enable this DNS activity using API, and I'm just making sure the BDDS IDs are captured correctly. The object ID, that's BDDS 1 and BDDS 2. I'm going to make a one call and update two BDDS servers in one shot. Okay, and I got the response. Let's copy that value, and let's check the status here, the config token. Okay, here it shows like it's finished, and the status is succeeded, which means it's enabled. Now let's go and take a look. The BDDS 2 activity, it's enabled with HTTP as an endpoint, and there are some exclusion, and DNS activity is running. Okay, let's compare the config here, the exclude parameters. Okay, now let's take a look at HTTP output, the data we received from BDDS 1 and 2. On the right side, I'm generating some queries for BDDS 1, and as you can see, it's already populated. Message, and it's a query with, yep, that's right, and that's our IP, server IP, and that's my source IP. Okay, now let's do the same thing with BDDS 2. Yep. Sequence is already generated. That's the response address. And that's how we configure DNS activity through API and setting up HTTP as an endpoint.